This video is about solving systems of linear equations by substitution. There are 4 steps in order to solve a system by substitution. You may want to pause the video while you fill in the blanks. Let's walk through the steps together. Number 1 is that we are going to try to solve one equation for one variable. So we want one variable to be all by itself. Look for a variable that doesn't have a coefficient if possible, because that would avoid having fractions that we have to deal with and would be the easiest one to get alone. Once you have that, you'll substitute in the expression into the other equation for that variable and then solve for the remaining variable. Finally, we'll use that number that we got from step 2 and plug it into the other variable's value. And of course, we need to write our answer as a point. There's one little tiny error on your notes. That should be from number 2, not number 3. Example 1. So we have our 2 equations. I wrote them in the box here for original equations. We have an orange equation and a blue equation. And our first step is to figure out if there's a variable that's already isolated or already by itself. And there is. In the orange equation, y is already by itself. So that means that I get to skip all of this first box. We will take that orange equation, y equals 3x plus 2, and we are going to use the expression to plug into the other equation. So we will take 3x plus 2, and we are going to plug it in for y in the blue equation. Here's what that looks like. X plus 2, and the expression will go into parentheses. 3x plus 2 equals 11. Then we'll solve it just like the regular equations we've been solving all the way back from chapter 1 and 2, or even when you first learned how to solve equations. So we'll distribute the 2, and x plus 6x plus 4 equals 11. Then we can add 1x plus 6x gives me 7x plus 4 equals 11. Subtract 4 from both sides, and 7x equals 7. Then we'll divide by 7 on both sides, and we get that x equals 1. Now that 1 goes in 2 places. That 1 is going to go into our answer because we write our answer as a point. So it'll hold the x portion. And then the 1 will also go back into our equation for x. So we're going to go back into that equation, y equals 3x plus 2, and we're going to replace the x with 1. So we'll have y equals 3 times 1 plus 2. 3 times 1 gives us 3. And 3 plus 2 gives us 5. So the other part of our answer is 5. Now, we talked a little bit in the last video about there's 3 ways that linear systems can have a solution. There can be one solution, it can be infinitely many solutions, or it can be no solution. This, of course, is one solution. I want you to go back to that table that we filled out, and we're going to fill out the bottom of the table now. So one solution is what was in this first column, and that's an example of what we just did as well. When you're solving them algebraically, which substitution and then in the next video elimination are both algebraic methods, you will be able to solve for each individual variable. So we got x equals something, we got y equals something. But notice we took our answer and we rewrote it as a point. That is very, very, very important. Then, for algebraic solving, it looks a little different when you have infinitely many solutions and no solution. If it's infinitely many solutions, what will happen is all of your variables will end up canceling out, and you'll be left with something that is a true statement, like 7 equals 7. That is a true statement, and so we would write IMS. In no solution, all of your variables cancel out, and you're left with a false statement, like 4 equals -1. That is a false statement, therefore it's no solution. But they all still fall under those three descriptions of solutions. There's one solution, which we call consistent and independent, infinitely many solutions, which we call consistent and dependent, and finally no solution, which we call inconsistent. So if you haven't finished copying this already, pause the video so that you can finish copying. And let's take a look at another substitution problem. So number 2, we have our two equations. Our orange equation will be the -x plus 3y equals -9. And our blue equation will be 8x minus 4y equals 32. And we ask ourselves always first, is there a variable that's already isolated? And in this case, there isn't a variable that's already by itself. We have to actually do that. So we need to pick which equation and which variable am I going to use. Remember I said that we want to pick the one that's the easiest. That would be the orange equation and solving it for x, because x doesn't have a coefficient other than 1 or -1 in front of it, which means I'm going to be able to avoid dealing with fractions and a longer solving process. So we'll take our orange equation and we are going to isolate the x. So we'll subtract 3y from both sides, giving us -x equals -3y minus 9. And then divide by -1 so that x equals positive 3y plus 9. We are going to take that expression for x and we're going to plug it into the blue equation for x. So 3y plus 9 is going to replace the x. 8 times 3y plus 9 minus 4y equals 32. And then to solve, we'll need to distribute the 8. So we'll have 24y plus 72 minus 4y equals 32. Combine like terms. So 24y minus 4y gives me 20y plus 72 equals 32. Subtract 32 from both sides and we'll have 20y equals 0. Subtract 72 from both sides, and we'll have 20y equals -40. Divide by 20, and y will equal -2. So that -2 is the y portion of our answer. And that -2 is going to go into one of our equations to solve for x. I'm probably just going to use this equation here because I won't need to do any actual solving. So negative 2 times 3 gives me negative 6 plus 9. Negative 6 plus 9 is positive 3. So it is one solution that is also independent and consistent. Let's take a look at number 3. We'll write our original equations down. X plus 2y equals 10, and 2x plus 4y equals 10. I don't already have a variable that's by itself, so I am going to have to do some isolation. So we'll have x plus 2y equals 10 would be the easiest one to get by itself because x is the only variable that doesn't have a coefficient other than 1. So we'll subtract 2y from both sides, which leaves us with x equals negative 2y plus 10. We'll take that expression and we are going to plug it into the blue equation for x. So we'll have 2 times negative 2y plus 10 plus 4y equals 10. Distribute that 2, and we get negative 4y plus 20 plus 4y equals 10. Combine like terms. Negative 4y plus 4y actually cancels, and we're left with 20 equals 10. Remember, we wrote down in our table that if all of our variables cancel and we're left with a false statement, then my actual answer is just no solution, which we would describe as an inconsistent system. Turn the page. Let's take a look at number 4. So for number 4, I have y equals 3x plus 4, and then negative 12x plus 4y equals 16. Now this time I do actually already have a variable isolated, so I get to kind of skip that whole first box here. And we are going to take the expression for y and plug it in for y into our blue equation. Now I notice that every time we've been able to take our orange equation and plug it into the blue equation. That's not always going to be the case. It just happens to be for these problems, so don't automatically think you have to use the first equation. You don't. You can use whatever equation is the easiest, but we're going to plug that in for y. So I have negative 12x plus 4 times 3x plus 4 equals 16. So to solve this, we'll need to distribute the 4. Negative 12x plus 12x plus 16 equals 16. Combine like terms. Negative 12x plus 12x, that cancels. And that leaves us with just 16 equals 16. Now that is a true statement, which means that there are infinitely many solutions, and you are able to use IMS to abbreviate that. Remember, with infinitely many solutions, if we were to describe this solution, we would say that it is a consistent and dependent solution or system. Take a look at number 5 before we jump into the word problems, because part of this standard is being able to write and solve word problems. So we have 8x plus 4y equals 20. Negative 6x minus 2y equals negative 16. I don't already have a variable that's by itself, and really I don't have one that sticks out to me as being super easy to get by itself. They all have coefficients other than 1. So you want to try to avoid using or getting a variable by itself that's going to create fractions for you to deal with. So the easiest way to do that is to kind of start with your first equation, first variable, and decide, are the other two numbers in that equation able to be divided evenly by this number? So 4 divided by 8, that doesn't go in nicely, so I don't really want to isolate x in the orange equation. Move on to the next one. 4, does it go into 8 evenly? Yes, so I could isolate the y so far, and 4 goes into 20, so that makes y a good choice in the orange equation. You'll notice that if you moved on here, the x wouldn't divide in evenly, but the 2 would have, so you could have chosen to isolate the y in the blue equation. Both would have given you an equation that doesn't have variables. Sorry, an equation that doesn't have fractions. So 8x plus 4y equals 20. We're going to isolate y. So we'll subtract 8x from both sides, leaving us with 4y equals negative 8x plus 20. Divide both sides by 4y, by 4, leaving us with y equals negative 2x plus 5. That's the expression that we will take and plug in for y into the blue equation. So the negative 2x plus 5 is going in for y. Negative 6x minus 2 times our expression, and it equals negative 16. So to solve, we'll need to distribute. And we have negative 6x plus 4x minus 10 equals negative 16. Combine like terms. Negative 2x minus 10 equals negative 16. Then we can add the 10 to both sides, giving us negative 2x equals negative 6. And finally, we can divide by negative 2 on both sides, giving us x equals 3. That's part of our solution, and that 3 is also going to go into our equation over here for x, so that we can figure out what y equals. Again, you didn't have to use that equation. You could have chosen either one of the original equations as well. But the 3 is going to go in for x. So we'll have y equals negative 2 times our 3 plus 5. Negative 2 times 3 gives me negative 6. And then negative 6 plus 5 gives me negative 1. So there's our solution, which we could describe as consistent and independent. Let's take a look at these word problems. I did give you 2 example word problems, and then I gave you kind of a template to walk you through the process here. So the first word problem talks about Hannah, and she has $11.20 in her jar, and it contains only nickels and dimes. There are 140 coins in the jar, so how many of each coin does Hannah have? No matter if you use my template or you solve it without the template, your first step should always be to label what are you labeling as X and what are you labeling as Y. You get that from your question. So the question was, how many of each coin does she have? So she has nickels and she has dimes. So our statements, or our let statements, one of them will be nickels and one of them will be the number of dimes. It doesn't matter which one you pick as long as you label it. And because it doesn't matter which one you pick, it makes it even more important that you do label it, or I won't know if your equations are set up properly. So now we need to write our system. And if you look back actually at the original problem, there's a clear set of two pieces of information that they've given us. One piece of information that they've given us is about the number of money, the amount of money in the jar. And the other piece of information that they've given us is about the number of coins total in the jar. Now those two pieces of information are going to make up the two equations in our system. Whenever you have two variables that you're looking for, you need at least two equations to find them. So we'll set up our number of money in the jar equation first. So we know that there's a total of $11.20 in the jar. And X is the number of dimes and Y is the number of, X is the number of nickels and Y is the number of dimes. Now there's something else that's not stated in the problem, but we know about nickels and dimes that has to do with money. And that is that nickels are worth 5 cents each and dimes are worth 10 cents each. So we can take that information and say, well, 5 cents is how much a nickel's worth. So if I multiply that by how many nickels I have, I will get the total amount of money that I have in nickels. Add to that 10 cents, which is how much a dime is worth, times the number of dimes would give me the amount of money that I have in dimes. And together should give me my total amount of money. Then the other piece of information that they've given us is how many total individual coins there are in the jar. Well, X is the number of nickels and Y is the number of dimes. So if I add those two together, I would get the total number of coins. And there's our system that we have set up to solve. Now to solve it with substitution, we would need to isolate a variable. So that would mean in this second equation, I would choose to get either X or Y by itself. It doesn't really matter. I'll choose to get X by itself. So we'll subtract Y from both sides, which gives me X equals 140 minus Y. That expression is what I'm going to take and plug in to the other equation. So we'll have 0.05 times our expression for X. That is going right in here. So 140 minus Y plus our 10 cents times Y equals $11.20. So 0.05 times 140 should be 7. And 0.05 times negative Y gives me negative 0.05Y plus 0.10Y equals $11.20. Negative 0.05Y plus 0.10Y gives me negative 0.05Y. equals $11.20. Subtract 7 from both sides, and we get negative 0.05y equals $4.20. We can divide that $4.20 by 0.05. Oops, that should have been a positive 0.05. You probably already caught that. My apologies. So we'll divide by positive 0.05 on both sides. And that gives us y equals 84. So there are 84, and y is dimes. So there are 84 dimes. To find the number of nickels, we can take that 84 and we can plug it in for y. So we have x equals 140 minus, and we'll put 84 in for y. So 140 minus 84 gives us 56. And that's nickels. Now this time we don't really want to write our solution as just an ordered pair because it actually means something in the context of the problem. So we'll write our solution as labeling the number of dimes and the number of nickels. Let's walk through one more word problem. It's about the total number of adults and children in a movie theater. There are 243 adults and children in a movie theater. There's 109 more adults than children in the theater. How many adults are there and how many children are there? Now that question at the end is what we're going to use to label our variables. So we'll let x equal the number of adults and y is the number of children. And then let's look back at the information that's given to us. One piece of information is about the total number of people in the room. A total of 243 adults and children in the movie theater. The other piece of information gives me a comparison of how many adults there are to how many children there are. So those are going to be the two equations that we set up. The total number of people in the room can be modeled by the number of adults plus the number of children, which should give us the total amount of people. And then the comparison. There are 109 more adults than children, which means that I need to take the number of children and add 109 to that to even figure out how many adults there are in the room. The nice thing is, this problem actually has a variable already solved. So I can take and plug in this expression in for x, which gives me y plus 109 plus y equals 243. Y plus y gives me 2y equals 243. We'll divide, whoopsie, y plus y equals 2y, but I still had to add my 109 to the end. Then we'll subtract 109 from both sides, which leaves us with y equals 243 minus 109, which is 134. Divide that by 2 on both sides, and we get that y is 67. Y is the number of children. So we're going to take that amount and we are going to plug it back in to this equation to figure out how many adults there are. 67 plus 109 would equal the total number of adults in the room. 67 plus 109 is 176 adults. So we can write our solution by labeling the number of children and finally the number of adults.